Hi everybody. So this week we're doing chemical weathering and carbon processes in our homework assignment. So last week we had a homework assignment which was just about transport. So we only had one conservative tracer in our BioRT model, which was chloride. And this week it's going to be pretty different. We're going to turn on reactions and we're going to track how calcite weathers in the subsurface and later how carbon processes are further affected by the decomposition of soil organic carbon. So I wanted to walk you guys a little bit through what the workflow for this week is going to look like in the GUI because it's a little bit different. So if I just share my screen. So starting off with the input files you're going to receive, you're going to download this file or this folder called Homework 6 Files off of Canvas. And inside the input folder, you're going to find a base case folder. So this folder has everything you need to run BioRT except for your Precip Chem files. And the reason for that, if we go back to the Homework 6 Files folder, is that we have actually two sets of precipitation chemistry files for different parts of the homework this week. So for parts A through C of the homework, we have these Precip Chem files, which only have these species. And then once we add our SOC and DOC, we need some different precipitation chemistry files. So the first thing you're going to do for part A is copy and paste these into your base case folder. And then I'm actually going to make a copy of this folder and just name it part A. So this folder now has everything you need to run BioRT. So next, you're going to open up the GUI and you're going to select the folder we just created. And so what you'll notice is that we have all of our soil.txt parameters filled in. We have our chem.txt parameters filled in. And you'll notice now that transport only is set to 0 because we are turning on reactions this time. But when we look at our primary, secondary, and mineral species, we only have pH. And if you look at the homework file, we actually have a lot more species than that. So we actually have calcium and bicarbonate. And calcite. And also we have our CO2. So these last two species over here, they are minerals, but we always add our minerals to our primary species list, even though they're not technically primary species. So we're going to add them to our mineral list as well. So starting off with calcite, and you'll use the default label here. And then you're going to add CO2 as well and also use the default label. And then once you've done that, just go ahead and overwrite the chem.txt file. And your chem.txt file should now be updated with your species. So then once you've done that, you can go into your calibration tab over here. And you'll now see that all these species have been added. So for our calcite and for our calcium and our bicarbonate, we only have our concentrations that we need to fill in. And this is, you're going to derive from the homework, which we give you all the values you need for every zone. But you'll see for calcite, which is a mineral, you have a bunch of different parameters. And we do also give you guys all of these parameters in the homework file. So you're going to fill those in for both calcite and our CO2, which is a gas, but in BioRT, in our simulation, we're going to consider it a mineral. So once you have all of those parameters filled in, you will go ahead and run BioRT, and you should see an output you'll see a bunch of species filled in this box over here, which is all of your output species. and then you can plot all of the species that we ask you to plot in the homework. So for the next part of the homework, I believe it asks you to change the log KEQ value for calcite, and this is where you change that value. And then once you rerun the model by clicking this button, create cine.txt and run BioRT, you can then click this button right here, which says plot one model run back, to compare the outputs generated from our different log KEQ values. Then, before you do the next part of the homework, I would recommend changing this KEQ value back to negative 7.3. Okay, so for part C of the homework, you are adding some additional species to the simulation. And these are our secondary species. So just like we added our primary species using the plus button and then selected them from the drop-down menu, you're going to do the same thing here. So for example, one of our secondary species is, let's see, it's a long list, but CaOH plus. So just like that, you would add all the rest of your species. Okay, and for the last part of the homework, after you've added your secondary species in part C, for part D, you're going to add a couple of new primary species, which are DOC, or dissolved organic carbon, and SOC, or soil organic carbon, which we consider a mineral in this simulation. So after you add it here, you will also add it to your mineral kinetics block. And you're going to use the test label. So then overwrite your chem.txt file. You see this error message, DOC was not found in the precipchem.txt file, and it's going to say enter a value to use or click cancel to use the default value of 1e negative 10 moles per liter. So we're going to click cancel. And the reason this error occurred is because we were still using the precipchem.txt and numx precipchem.txt files from parts A to C. So before we run the next, before we run part D, make sure to go to this folder and copy and paste those precipchem files into the folder you're running from. Okay, cool. And now you'll see that we have our SOC and DOC here. So yeah, just make sure to do that before actually running BioRT, or else you won't have the correct precipitation chemistry. And then finally, the last thing I want to point out is once you have your simulated species here and you can visualize them on this plot over here, there's an optional part of the homework which talks about calibration. So to do calibration, I've set up all of the species you need to calibrate to over here. So if you click DIC and calcium, you can see that these are our actual observed values. They're real data we have from this catchment, and what you're going to do is basically try to get your DIC and calcium simulated values to match these as closely as possible. So one way to measure that is by tracking the efficiency, or NSE. So if you click track NSE, every time you plot DIC observed and DIC simulated together, you'll see an NSC value pop up at the top of the plot. Same thing for our calcium. So to track your NSC value, just make sure to have these checkboxes clicked. And then also one thing I want to point out before I end this video is that at some point you're going to have to plot calcite rates. So those will also show up in your simulated species box, but to see those rates, you're going to have to click toggle rate plot, which will add a third plot in the middle of the screen here that is specifically for rates. So, I hope that helps a little bit with the homework. Please let me know if you have any more questions, and I will try my best to help you. I think it's much more likely that there will be problems with bugs and, errors in the code this time around. So please do not hesitate to ask. And yeah, email me sooner rather than later so I have time to help you debug and get it running for you. But I wish you guys luck on the homework, and again, don't hesitate to reach out.